Welcome back, ladies and gentlemen. This is day 5. All right. Last day of assigned notes. Okay? So, let's finish it up here. Hopefully, you guys are keeping up with your studies. Any questions, you guys, please email me and we can try to resolve this, okay? I've got a lot of free time. Not a lot, well, I don't want to say a lot of free time, but a lot more since we're not in school. And so, utilize me, all right? I got my email. I'm checking it on a regular basis. So, anytime you need further instruction, please email me, okay? Or contact me. We could set something up, okay? All right. Sorry, there's a hair on my page. All right. So, Shay has recently begun kickboxing and purchased training equipment as modeled in the diagram below. The total weight of the bag, pole, and unfilled base is 270 pounds. The cylindrical base is 18 inches tall with a diameter of 20 inches. So the dry sand used to fill the base weighs 95.46 pounds per cubic feet. Okay, so this right here is its density. Okay? Now what we need to do is we first need to find the volume of this piece down here. And then also it says, to the nearest pound, determine and state the total weight of the training equipment if the base is filled 85% of its capacity. So our game plan, right, is to find the full volume of this section down here, okay, that cylindrical base, and then we're going to find out what its volume is at 85% full. Then once we find its volume, we take its volume and its density, and we multiply those together to get our mass, right? So we get our mass, remember, is the density times the volume. Okay? So in order to find the mass, or the weight, that's what it means, the total weight. So when we're talking about weight, we're talking about mass. In order to find the total mass or weight of this kickboxing equipment, okay, we got to find the volume of this section down here. Okay, so how do we find the volume of a cylinder? Well, the volume of a cylinder is pi r squared times its height. Okay, so they give us its height, which is 18. Okay, but what we need is we need our radius. So they give us our diameter. Don't forget our diameter is just twice the radius. So when you divide 20 by 2, that will give us 10. So our radius is 10. Okay? So now, in order to find what this volume is, I go pi times 10 squared, which is 100, times 18. Right, and you should get 5654.86676, and this is what? In inches? So inches cubed. Okay? All right. Now, also, let's think about this. I'm going to, actually, there's a number of ways you can there's always a couple ways you can kind of do these problems. I am going to, all right, so this is our volume when it is 100% full. I want to find its volume when it's 85%. Okay, so I'm going to set up a proportion. All right, so my proportion looks like this. Right, when it's 100% full, or a 1, okay. All right, so let's think about this for a second. What I just did was I just took 100% and I turned it into a decimal, which 100% as a decimal is just 1, okay? So 100% of its volume is 5654 0.86676. Okay, and I want to find out what its volume is when it's 85% full. So you cross multiply, you get x is equal to 0.85 times our volume. And so when our training equipment of its base is 85% of its capacity, what it's saying is we are at that right there. So this is our, what is this, inches cubed, right? So that is our volume of this base when it's 85% its capacity, or 85% full. Okay, so now we know what the volume is. We know what our density is. And so now we need to find out what is its mass. What is the weight of this cylinder? Okay, when we're just talking about this piece down here. Right, we're not talking about the whole thing, we're talking about the weight of this thing filled. All right? So, in order to find that, okay, we're going to have to do some metric conversions. Okay, so here is this right here, 0.637, oops. All right, and this is inches cubed. Crikey. Okay, multiplied. All right, so in order to find our mass, we're going to multiply our volume and our density, right? Mass is equal to density times volume. Okay, so this is our volume, this is our density, and our density was 95.46 pounds per cubic foot. Okay, so it's pounds per feet cubed. Okay, so whenever we're doing metric conversions, our goal, okay, is to try to get this thing to cancel, or try to get these units to cancel. So right now, if I multiply this as is, okay, none of my units are canceling. What I want to be left with, I want to be left with pounds, right? Because we're looking for its mass. So I want to be left with pounds, which means I want to get feet and inches to cancel out. And at this point right now, they're not canceling, right? They would just be multiplied out. So in order to do that, all right, so let's think about this. 1 foot is equal to 12 inches. Okay, but we don't have 1 foot, we have 1 foot cubed. Okay, so 1 foot cubed is actually equal to 12 inches cubed. All right, so let's think about this further. All right, I'm going to put this up here. All right, so let's think about that. Why did I just do that? Well, because when I cube all of that, I'm going to get 4806.6376 for 1 inches cubed, okay, times 95.46 pounds per cubic foot. And now I have 1, because 1 cubed is just 1, so I have 1 foot cubed. And then 12 cubed is, I don't know that off the top of my head. Do you guys? I don't. 1728 inches cubed. All right, and so now, whoops. Now if you look at our units, what's canceling? Well, inches will cancel. Feet will cancel. And I'll be left with pounds, which is exactly what we need because we're trying to find the weight of this thing. All right, so we're going to multiply all that out. So we're going to have 4806.6376 divided by, oops, I'm sorry. Yeah, oops. So we're going to have that times 95.46 okay, times 1 over 1728. So when we multiply these two pieces together here, we have to divide it by 1728. So everybody go ahead and do this. So 4806.6376 times 95.46. All of that divided by 1728. And you should get a mass of 265.53 pounds. All right. Now, we're safe to leave it in pounds because if you look up in our problem here, all right, our unfilled base is 270 pounds, or at least our unit of weighing there, of measurement, I guess, is in pounds. So we just have to remember that this right here isn't our answer, okay? This is the weight of that cylinder when it is 85% full, okay, with dry sand, all right, because that's what we use to fill it. We use dry sand. So now I got to take this 265.53, and I'm going to add 270 to it. Whoops. Heyo. 535.53. And it says to the nearest pound. Okay, so because we're rounding to the nearest pound, all right, we're going to round up. So it's going to be 536 pounds. And that is your answer to number 20. Okay, so these density problems do have a lot going on here. Not only are you trying to find the volume, let's find the volume, we have to find the mass. And once we find the mass, we have to add it to the other mass. In this case, it was the weight of the kickboxing training equipment when it was unfilled. Okay, so that is our answer to number 20. Okay. Number 21 is not too bad. All right, I know I say that a lot, but so we're talking about a standardized golf ball has a diameter of 1.68 inches. The material used to make the golf ball weighs 0.6523 ounces per cubic inch. What is the weight to the nearest hundredth of an ounce of one golf ball? Okay. So, anytime you see something where it's weighs 0.6523 ounces per cubic inch, well, that's just a density. So they give us their density, all right, and they want to know what the weight is. So they're looking for the mass. So what is the weight? They're looking for the mass. All right, so let's draw our triangle. MdV, all right, so in order to find the mass, it's equal to density times volume. Okay? So, all right, neighbors must be cooking something good downstairs. I can smell it. All right, so in order to find the mass, we have our density, but we need to find our volume. Okay? So in order to find the volume, we're going to have to use this piece of information here. So they tell us the diameter of our sphere is 1.68 inches, which means, okay, if we were looking from the top, all right, our diameter, or that measure from across from one end of the circle to the next, is 1.68 inches. Okay, now take a look at the density before I start doing anything fancy. All right, it says ounces per cubic inch. Okay, so we don't have to adjust our diameter for anything. All right, we don't have to worry about any metric conversions. Okay, because our density is in terms of ounce per cubic inch. So when we find our mass is going to be in terms of ounces. Okay, so that being said, in order to find what our rate are, all right, the reason why I'm talking about the diameter is because in order to find the volume of a sphere, it's 4/3 pi r cubed. So in order to find what our volume is, we need our radius, which our radius is just 1.68 divided by 2. I don't know what that is off the top of my head. 0.84. So our radius is 0.84. So we're going to go 4/3 times pi times our radius cubed. All right. And so make sure you're using parentheses. 4/3 times pi, times 0.84 raised to the third power. All right. So you should get 2.4827, and this is our volume, so this is inches cubed. Now if you look over to the left, you'll see, oh, they have 2.48 there. All right, don't fall for that, okay? They want you to just immediately say, hey, we found the volume, we're done, okay? This isn't one of those types of problems, okay? So I'm just going to try to bring this over here. Okay, save room for that next problem. All right, but anyway, don't fall for that here. Okay, even though we found this number here that does appear as one of our answers, this is our volume. This isn't our mass. In order to find our mass, okay, we need to go density times volume. All right, so we have our volume, we have our density, so 0.6523. Right, let me clear some space here. So mass is equal to 0.6523. Okay, ounces, ounces per inches cubed, okay, times my volume, which is 2.4827 inches cubed. Okay, and what happens here, right, inches is over 1, right? You can always put anything over 1, right, as a fraction. Our inches are going to cancel, and we should be left with something in terms of weight, in this case ounces. So ounces are the the unit we have left, so we know we multiplied correctly there. So 0.6523 times 2.4827. You should get an answer of 1.6195 ounces. Okay, so this is to the nearest hundredth. So I would go 1.62 ounces is our answer. And do we see that next door? Yes. We do see that response. Okay? All right. So that's the answer to number 21. A little bit tricky there, but nothing too crazy. Okay? And again, this formula right here will appear on your guys' reference sheet, on your regions. So you don't have to memorize it. But never hurts to memorize it. Save yourself some time on the region so you don't have to look up all your formulas. Okay? There's value in that. Now, let's take a look at number 22. Even though the problem number's over here, the problem's over located this way. All right? So number 22. So what is the area of the top of the installed countertop to the nearest square foot? Okay? So what we want to do is we want to find the area of this countertop. Okay? And then we're going to have to subtract that area by the area of the sink, okay? Because we need to make, in order to make this countertop, we have to make sure that we leave space for the sink, okay? So we're going to find the area of the larger shaded region, subtract it by that area of the sink, and that should give us the area of the countertop, okay? So there's a number of ways you could do this. My suggestion is to chop that in two different pieces, okay? So if this is 2 right here, this distance right here, and this whole piece is 5, that means this length right there is 3. All right. Okay. And I think that's the only other piece we need. Now, if you notice, all right, of course they love throwing stuff like that on there, okay? Our units of measurement for the sink are in inches. So we're going to have to convert that to feet. So 8 inches So 8 inches, all right, times, okay, so 1 inch, I'm not sorry, so 1 foot is equal to 12 inches, okay? So what I just did there is I set up a conversion to convert my 18 inches into feet, okay? So if you notice the inches, those units will cancel, and our length is going to be 18 divided by 12, which is 1.5 feet. Okay? That's what that equals right there. So this is actually 1.5 feet. And to convert the other one, so it's going to be 21 inches times 1 foot is equal to 12 inches. So again, the inches cancel, so you're left with 21 over 12 feet, which is equal to 1.75 feet. Okay. 1.75 feet. Now, everything's in feet, okay, so all I am left to do at this point is find the area of these rectangles here. So I'm going to find the area of this first rectangle. And then I'm going to subtract it by the area of this little square here, that little rectangle there as well. All right? And then our last rectangle, I'm going to find the area of, don't forget, this piece over here. Okay? So let's break it down here. So let's do this first one here. This one right here, right? 3 times 2. Well, the area of this one is just going to be 6 feet squared. Okay? Done. Now let's take a look at this one here. Okay? To find the larger area, it's just going to be 2 times 8, which is 16 feet squared. So this is 16 feet squared. And then this little square in the middle is 1.5 times 1.75. Whoa. Which is equal to 2.625 feet squared. Okay, that's the area of that little square. So, in order to find out what the total area of that piece is, you're going to go 16 minus 2.625. Which is 13.375. And then I'm going to add this piece up there, 6 feet. So then 13.375 plus 6 feet is equal to 19.375 feet squared. And it says round to the nearest square foot, which means we would round down. And so our answer is number 4. All right. Number 23 and 24, and we are done, folks, with this week. Okay, so a cargo trailer pictured below can be modeled by the rectangular prism and a triangular prism. Okay, inside the trailer, the rectangular prism measures 6 feet wide and 10 feet long. The walls that form the triangular prism each measure 4 feet wide inside the trailer. The diagram below is of the floor, showing the inside measurements of the trailer. Okay, so here is our side view, if you will, and then here is our top view. Okay, both of these are useful information. We need to solve this problem here. Okay, so what we're looking for here is if the inside of the trailer is 6.5 feet, what is the total volume of the inside of the trailer to the nearest cubic foot? Okay, so our goal here is to find the volume this entire section. So let's begin. First thing we're going to need is what is the volume of a general prism? Okay, the volume is big B times the height. Now let's not forget the big B, big B stands for the area of the base. Okay, so we're looking at a rectangular prism and a triangular prism. So let's look at the rectangular one first. Okay. Come on. Touchy little thing. Perfect. Okay, good enough. So let me connect these sides here. Okay, there's our rectangular prism. Okay, so let's look at the dimensions for this rectangular prism. Okay, they told us that our height, okay, so the height of this trailer is 6.5 feet. And if we were to look at the top view, you would notice that this measurement is 6 and this is 10. Okay, so rectangular prisms are actually kind of nice because really all we're going to end up doing is multiplying these three numbers together. So the area of the base is really just 6 times 10, and then we multiply the height. So to find the area of this rectangular prism, it's 6 times 10 times 6.5, which is equal to 60, 390 feet cubed. Okay? 390 feet cubed. All right. So now we need to take this and we need to add it to the volume of that triangular prism. Okay, so I'm going to kind of cheat here. Look at that. Well, move over just a little bit. Perfect. Okay, so what we're looking at, whoops, actually, let me go back. I want to spread out just a little bit more. Okay. All right, so there's our triangular prism. Okay, we don't want to look at it like this. Okay, how you want to look at this thing is we want to actually set it so that our triangle is actually sitting on itself. Okay, so that's how we want to kind of picture this thing. Right? So now, it almost kind of looks like a cylinder, right? Or at least how we would set up a cylinder. It doesn't look like a cylinder, but certainly how we would set up, how we solve our cylinder problems, right? Kind of put this up on its edge like this. Okay, something like that. All right. So, same thing kind of goes for these triangular prisms here. Okay. So what they've given us these lengths right here. Okay. They've given us the height of this thing. Remember, our height is 6.5. All right, and then this length right here is just 6. Right. It's just this length right here. Okay. That is just 6. So what we don't have, though, is we don't have the height of this triangle, all right? Don't forget, in order to find the volume, big B times little h. In this case, our big B is the area of a triangle, so it's 1/2 base times height times height. Okay, so that is what we are looking for here. All right, so in order to find these pieces right here, okay, what happens is we end up dividing this section in half. So this is no longer is 6, this becomes 3, and this becomes 3. Okay, so we divided that piece in half. Also, this is an isosceles triangle, so that lets you know that you're able to do so. Okay, you draw a perpendicular line from this angle down to that side. All right, it should split up both of these measures right here. Okay, so anyway, so that's what we're looking at. So in order to find our height, all right, let's take a look at our triangle here. So we're looking at our triangle here. Whoops. All right, it's got a right angle. This is 3. This is 4. In order to find that piece right there, you guessed it, we got to use Pythagorean's theorem. Okay, so a squared plus b squared is equal to c squared. Now, this length right here is always your c, or your hypotenuse. Okay, so the side that's always located directly across from your right angle is your hypotenuse. Okay? So, being said, I'm going to go 3 squared plus b squared is equal to 4 squared, which is 9 plus b squared is equal to 16. Subtract 9 from both sides, you get b squared is equal to 7. And so our height is equal to the square root of 7. So that is our height. And now we can finally find the area of that base. So it's going to be 1/2. Our base is 3. And our height is the square root of 7. So that is our big B, all right, the area of the base. Don't forget the area of a triangle is 1/2 base times height. And then now to find the full volume of this triangular prism, I need to multiply all that by 6.5. Okay? And by doing so, and make sure you're using parentheses for all these. Okay, so 1/2 times 3 times the square root of 7 times 6.5. Okay. Whoa. Yeah. Okay. Should get 25.79607. It says round it to the nearest cubic foot. Well, first off, hold on a second. What did I just do here? Oh, right. So this is our volume of our triangle, right? This is in feet cubed. So now I have to take this number and I have to add it to this number up here. Okay, so I will round here in just a second. So I'm going to go 390 plus our second answer, which is 25.794. All right, and then you should get an answer of, when you add these two together, you should get 415.796, and it says round it to the nearest cubic foot, which would be 416. Oops, sorry, feet cubed. Okay, so your answer is 416 feet cubed. Let me put some stars around there so people know where to find it. Okay. And last one, last but not least. Okay. So, the pyramid shown below has a square base, a height of 7, and a volume of 84. Okay? Now we don't know what units this is, but that's okay. All right? So it has a square base, which means, oops, that's a bad square. That means our base, okay, all of its sides are the same. So in order to find the area of a square, it's just going to be side squared, or in this case, x times x, or x squared. Okay? So this is the area of our base. We don't know what our area is, but we do know our volume. So let's go back to what the volume of a pyramid looks like. Okay, so it's 1/3 base times our height, where the B is the big B. Don't forget the big B stands for the area of the base. Okay, so in this case our base is a square, so let's kind of fill in the blanks here. So here's our volume, 84, 1/3. Our big B, all right, we don't know what our sides is, so we're just going to use x, okay, because we're accustomed to x, so it's going to be x squared, okay, because don't forget the area of a square rectangle is length times width. So in this case, because our length and width are the same, it's just x squared. And then our height in this case is 7, and so now we just solve. All right, so 84 is equal to 7/3 times x squared. Make a better 7 there. Okay. And so we multiply both sides by 3/7. Multiply both sides by 3/7. That's the multiplicative inverse. So 84 times 3 divided by 7. And you get 36. is equal to x squared. Take the square root, and x is equal to 6. And do we see that answer up there? We sure do. All right, and so that is it, folks. Woo! We made it. All right, the end of week 1. So hopefully you guys have completed all this stuff. All right, be checking your answers. I'll be sending this answer key momentarily here as soon as I get this video downloaded. And so any questions, guys, be sure to make sure you're contacting me. Okay, I've been checking my email on a regular basis, so let's make sure that you guys are utilizing that. Okay, make me work. Okay, ask me questions.